In this series of videos, we want to specifically focus on how to graphically display and summarize quantitative variables. So we're going to start by looking at an example together on the age of our presidents at inauguration. So here you can see a table of data, and on the column here we have a list of names for all of the presidents, and then moving to the right we've got age at inauguration along with some other columns. So remember that the variable age is considered a quantitative variable. And so we want to look at how do I display, using both a table and a graph, quantitative variables. So we know from a previous lesson on qualitative variables that we can always display our raw data in a summarized table. So let's just start by creating a table for this raw data here. Remember, we go to Stat, Tables, Frequency, and I'm looking specifically at the age of inauguration. Now, because we've already defined what it means to be a frequency and a relative frequency value, we're going to leave these two selected and then hit Compute. You'll notice that there's a pop-up window that just now came up when I tried to do this in StatCrunch. It says, whoa, there's lots of unique numeric values for this column you want to try to create a table from. Do you want us to bin it for you? It's called. So let's just click OK and see what happens when we do that. So here I have a table that StatCrunch created for me. And you'll notice that we have a frequency column as well as a relative frequency column for their ages at inauguration of the presidents. But let's talk for just a moment on what StatCrunch automatically did for the data. Remember, it said there's a lot of unique values in this data set. So for their ages of the presidents, you can look over here at the column next to my table. We've got ages that are like 57, 61. We have a couple of more 57s, 58, blah, 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 right? And so on. So what we're going to do, since we have so many different values that could occur for these ages, rather than making a bar graph the height of that age, we're going to group the ages into what's called a class or a bin. And that's what you see in this column here on our table. We let StatCrunch create the bin for us, but we're always able to state what type of bins, what type of classes and their widths on our own within StatCrunch, but let's just talk about what they did. You can see here that they grouped the ages of the presidents by years of 5. So in the first row, we have presidents who were aged 40 to 45, 45 to 50, 55 50 to 55, 55 to 60, and so forth. And then if we come here for the first row we're looking at, that class that's 40 to 45, we can see that there were 2 presidents that fell within that age range, and that the proportion or the percentage of presidents would be about 4% of the presidents were aged between 40 and 45. So the table we created based on our quantitative raw data, there's ages at inauguration, gets summarized by grouping those ages because it's the most concise way of us displaying that information. And then just like in a qualitative display, those frequency and relative frequency counts for each of the categories, or in this case, for each of my classes, is given in the table. So it's not going to look any different when I go from qualitative to quantitative frequency and relative frequency tables. But let's go ahead and let's see, how does this differ when we try to graphically display this information? So I'm going to go to Graph, and this time with quantitative variables, we're going to choose histogram. So histogram is the first type of a graph that we're going to create for quantitative variables. Let me move it over here to the side. We want age at inauguration. And you can see here that if I wanted to change my bins, I could do that in this part of the pop-up window. But I don't want to change anything right now, so I'm just going to hit Compute. Let me move this to the side over here, and now you can see that we have what seems to look like a bar graph, but instead of us calling this a bar graph, we actually call this type of a graph a histogram. Now, a histogram is going to still be bars, but notice that all of these bars are touching, unlike in a bar graph where each bar stands for the category in our qualitative data. In a histogram, each one of these bars is going to represent the class that was defined when we grouped the data into a range of values. So the height of my bar still is going to represent the frequency or proportional height of that category, or that class width, I mean to say. So let me come over here. I'm going to hover my mouse over this tall bar for just a moment. So in this particular part of the graph, we're looking at ages at inauguration that are ranging between 50 to 55. And this corresponds with the table that you see on the screen as well. But what does this bracket next to the letter 50 and the parentheses on the right side of 55 indicate? Well, maybe when you were thinking about these classes here from our table, if I've defined my class to go from 40 to 45, and then the second class under that goes from 45 to 50, we have to determine at what point are we going to cut off this rightmost endpoint. Because do I include 45 in the first row, or do I include 45 in the second row? And that's where these brackets and parentheses indicate what's going on. In the math world, we have decided that a bracket indicates that I can include that number. The parentheses indicates that I do not include that number. I can go all the way up to, but do not include that number where the parentheses is falling. So what this is implying then in this particular bar is that we're going to include all of the ages between 50 and up to, say, 54.99999, because that's not quite at 55, but it's pretty darn close. So I can get right up to that 55, but I can't include it. And the reason for that is because notice when I move my cursor to the very next bar, now I have the bracket at the 55, meaning I'm including 55 instead in this set of values, but I'm going to move all the way up to and not include the number 60. So I hope you get an idea of how we are including these values in their classes. Let's go and let's also reproduce this graph. So I'm going to come back to this graph and let's change it from a frequency to a relative frequency this time. Again, I'm going to leave everything the same, but when I produce the graph again, hopefully you can remember what it looked like a moment ago. But just like we saw when we were showing bar graphs in qualitative data, it doesn't make a difference whether I've displayed a frequency or a relative frequency graph, because the overall shape that I'm interested in is going to be the same. Those height of the bars are going to be the same relative to the display of the data. So in other words, if I'm trying to read this graph and get an overall sense of what kind of picture I can develop for the underlying data, it doesn't matter if I look at a relative or a regular frequency histogram. The last thing I want to point out as far as histograms are concerned, let's remove both of these displays. And I want to show you using this applet under the histogram with sliders. Let's play around with that age at inauguration one more time. So this graph should by now look familiar to you. It's the same one we've seen when we graphed our histogram using both frequency and relative frequency. But this time, I want to see what happens if I change the width of these bars. Remember, we let StatCrunch just automatically set up how wide we wanted to group these. We were okay with saying, sure, let's just group them by ages of every 5 years. But if I were to take this slider bar down here and let's make it, adjust it to the left. So I'm going to change the width of these bars by the values that you see on the screen. In other words, I'm going to go where I've stopped now, I'm going to say group the ages by 2 years. So every 2 years is going to be grouped. And what do you notice is happening to the bars themselves? As I decrease the size of the width of my bars, I'm actually creating more bars up here on the screen, and those bars themselves are becoming skinnier. So I still have an idea of the shape, but maybe not as good of an idea of that shape as I do here when we have it on what was defaulted. Now, if I increase the width size, so let's say I increase it to maybe include grouping by every 9 years for whatever reason, notice that the number of bars decreased. So I get fewer bars, and I get bars that are wider in their bin width. So there is kind of an art to the bin width here. We're not really that interested in you picking that one number. I typically will let StatCrunch default to whatever it thinks is an appropriate bin width, but understand that you have the ability to change the width of your bins when you go to your histogram and you select where you want it to start and what width you want to use. This applies when we create both histograms as well as tables. So we have the same option in here. I can decide where I want to start my bin at, as well as how wide I want my bin to be. So those are some things that we want to consider when we're creating these histograms. So to just summarize that graphical display idea for quantitative variables, this is our first graph that we can create using quantitative data. Histograms are going to be determined and characterized by having a class or a grouping of numbers where we can determine how wide we want to group those values, how wide that class width is going to be. Just as in a bar graph, the height of our bars in the histogram are going to be relative to that category or that class size. And the characteristic for histograms in this case compared to bar graphs are that the rectangles are going to have the same width, and this time they're actually going to touch. So this is our first graphical display for quantitative variables, and you also saw at the beginning of this video, how do I graph or how do I display the data using frequency and relative frequency tables.